Greetings and welcome. This is the second video in a series of videos reviewing lists in Python. So our goal for today is to better understand the operations we can perform on lists. So when we talk about operations, that's kind of an abstract idea. In Python and in many other object-oriented languages, operations can take two forms. We can have operators, like plus and times and square brackets and less than and greater than, that work on operands where one or more of the operands is in fact a list. Or we can have methods. So methods are functions that are defined for an object like a list, and a list is an object, and they have arguments. And so the arguments can be thought of just like I think of the operands for an operator. They're refining and saying, for this particular operation, how do I want to customize it in order to do what I want to do? In the first video, we said there were four categories of operations that we want to look at. One was to create a list. This is also called construction. Second, which was also covered in the first video, was access. And access we can break down into access of a single element, or we can access a sublist. Most of these things are also true for tuples as well as lists. In this video, we're going to focus on mutations. So this is changing the list. And we're also going to look at a specialized category of access operations where we search a list for a particular element. Now, for the purpose of this tutorial, we're going to use a Jupyter notebook. And you can see that Jupyter notebook on the left-hand side of the screen here. I'm highlighting the name of that notebook. It's called listinstruction2.ipynb, and that should have been given to you by your professor. In this notebook, mostly I'm going to show segments of code, and then I'm going to have links that go to a Python tutorial that allow us to visualize what happens when we execute that code. At the top here, I give myself a basic outline for the types of examples that we want to demonstrate through the rest of this tutorial. So with that preliminary set, let's go ahead and move on. So we're going to start with where we left off in the previous tutorial and remind ourselves, how do I create or construct lists? So in this first example, we see mylist0 as a Python variable that's getting set to an empty list. So that's how I create a list that starts with no elements in it. MyList1 is the second Python variable that references the list that consists of the 3 string values, eggs, milk, and bread. MyList2 is very much like MyList1 in that it is a set of elements of these strings for eggs, milk, and bread, but they're in a different order, and I constructed the list by using variables instead of constant literals to specify the values in the list. And MyList3 is an integer list that uses integer constants, integer variables, and expressions with integer variables, just to show the different variety of ways that we can construct lists. All right. So moving on, we're going to assume that that was covered in the last video and that we have a good understanding of that both from that video and from our CS1 class. We're going to take a look at the first category of mutation. So we're changing a list, and we've got a couple of varieties of mutations. We may want to change the value of a single element. We may have an existing list and we want to add a single element to an existing list. Third category, we may have a first list and a second list, and we somehow want to compose or aggregate 2 lists together. And then there will be a couple other examples after that. So let's look at changing the value in an existing list. So in this example here, we can see that I am creating my list 6 as a list of integer numbers. I then print the list, and then I show examples of modifying a single element in the list by using assignment. So we'll go to the visualization. This is taking us to my Python tutor, and we see the exact same code, but here we can visualize execution. When we visualize execution, we see the code here on the left, and on the right, we see an area for the print output. Whenever I do a print, it will appear here. And whenever I create Python variables, the name of the variable will show up in the frames, and the values will show up underneath objects. So beginning, we create my list 6. I'm going to expand this because we don't need the whiteboard as much right now. And we see my list 6 is a Python variable that refers to, and we use an arrow to show this reference, something in the value space, an object, which is a list with 9, 12, 1, 14, 9, 22, 21, 21. Right? And the indices give us the position within the list. We start at 0 and go up to 7, and there are 8 elements total in the list. After I print the list and that result shows up here, now I'm going to modify a single element. When we modify a single element, I specify the element in the access operator brackets. That's the begin square bracket, end square bracket. I specify 0 as naming the element I want to change. And then I use assignment, and the right hand of the assignment gives us the value that that's going to become. So my list 6 sub 0 just changed to 13. In the second example of assignment on line 7, we see a little bit more complex thing where I'm getting a value from the index 3 element, a value from the index 4 element. So that's a 14 and a 9. I'm adding those together. That gives me the value 23, and then assigning that to index 2. Index 2 became 23. My list 6 is similar to what we just did in line 7, where I'm going to change index 1 by subtracting 1 from its current value. So my list 6 sub 1 is the value 12. I'm going to take that value 12, subtract 1 from it, get 11, and then update the index 1 element to be that value 11. I can also use negative indices. Negative 1, we know, refers to the last element in the list. So negative 1 is the same as specifying index 7. All right, I set that to 25. This is something you probably did not see in your intro class, but we can use assignment and use a slice specification on the left-hand side of the assignment to say, I want to change the values starting at 2 and going up to but not including index 5. So that would be the 23, 14, 9, that 3-element sublist, I'm going to change to be in one step 8, 5, 1. Lo and behold, 8, 5, 1 became the values at indices 2, 3, 4 respectively. I can use negative indices with slicing on the left-hand side of an assignment. And so I'm going from -3, so index 7 is the same as -1, index 6 is the same as -2, index 5 is the same as -3. So I'm starting at -3. I'm going up to but not including index -1. So that means I'm specifying the sublist 22, 21 and setting that to the value 5, 4. Right? So these are examples of changing a single element in a list. We'll now get set up for an example of assignment that is not legal. Why might something not be legal in an assignment to change the value of an element? Well, one of the main reasons that an illegal thing happens would be if I use an index that is not a valid index. So my list 6 is the same value set as before, so its valid indices are from 0 up to and including index 7. So this line here is perfectly valid because I'm using an index that is in that range, but the next line says I'm going to try and update at index 8, but index 8 does not exist. This will give us an error. Right? Similarly, if I use negative indices, this line here, -8, refers to the same index as index 0, and that's a perfectly valid thing to do. But if I go one further than that to index -9, then that's not legal. And so this will give me an error. And the last example is simply showing that because tuples, unlike lists, are immutable, I cannot change them once they've been created, then any assignment, whether it's the first element, the last element, or anything in between, is going to cause an error. All right, so let's go to cell visualization and take a look at this one. All right, I create my list 6. Looks just like it did in our previous example. I create my tuple 6, which has the same values, but instead of being a list object, it's a tuple object. All right, then I continue on, and my list 6 sub 7 is equal to -1, so that's going to change the index 7 element to be -1. Perfectly legal. The next statement says my list 6 sub 8 is equal to -2. That's looking for an element that doesn't exist, something that would be out here that's beyond the current limit of the list. And when I say try and do that, I get the following error. Index error, list assignment index out of range. Now, typically, if you were running a Python script or you were using a notebook and you encounter an error, you get an indication of what was being run, the sequence of function calls, what's called a stack trace. But at the end of that listing, you would see this index error. Okay, so we're going to edit that code and comment out the line that's giving us an error. And then we're going to uncomment out the one that will give us an error when I use negative indices, and we'll visualize that execution. So continuing the same place, line 9 is valid because index -8 is the same as index 0, and I'm going to change that to -3. Perfectly fine. Going one beyond, so a negative index that whose equivalent is less than 0 is illegal, and I get another index error. Now our final example within the example here, let's change this back so that we can get to my tuple 6 assignment. If I try and change the first element of my tuple 6, because tuples are immutable, they cannot be changed once created, this will give us an error. And so moving quickly on to that and take a look at the error that we get. Type error. Tuple object does not support item assignment. It's a way of saying I just tried to change something that is not changeable. Right? It's important for us to understand when we see an error to be able to look at the error and try and understand what the error is trying to tell us, because that will help us to debug our problem. Our next example is trying to combine a list and an item. In other words, we have an existing list. It might be an empty list, or it might have a list with 100,000 elements in it, but our goal is to simply add one more element. Now, to do this, we want to do it in place. We don't want to create a brand new list. We want the list as it exists in the object space to be changed to add another element to it. All right? And in order to do this, we're going to use a method called the append method. The append method is invoked by having an expression that gives us a list and then after that, I'm going to put in purple here the syntax that's required, and in light green is going to be what we substitute for. We change based on the context of the code that we're trying to write. So after the list expression, we have the period, and then the name of the method, a begin paren, and an end paren. And in between those parens, as an argument, we're going to specify an item value. All right, so we get to choose the list expression, we get to choose the item value, and we're required to have the period, the append, the begin paren, and the end paren. All right, so that's the example that we're going to take a look at here. So in this example, we're going to create a list, mylist7, that has 5 elements. And then we're going to perform append twice. So our choice for list expression is the name of a Python variable called mylist7. Our choice for the value to append, 4, and then 19. And then we're going to take a look at some things that are common mistakes. What happens if I try and do append and what I specified as the argument wasn't a single value, but in fact was a list? What happens then? All right? And a second common mistake is when we use a method, instead of having the method change it in place, we take the result and reassign to a beginning list, which is something we commonly do, for instance, with strings or with tuples. We use a plus in Python to create a new object, and we want to see what happens when we use that kind of assignment here with the method for append. Okay, so the visualization itself. We create the list. We've got a 5-element list, 9, 12, 1, 14, 5. My list 7 refers to that list. Okay, so when we invoke a method on a mutable object like a list, we do not do assignment. So we say mylist7 dot append, right? That's consistent with the syntax that I'm showing over here. We append a 4, and now we've created an index 5 element that didn't exist before, but while I created it, I didn't create a new list. I did it in place. We do the same for 19. All right, so common mistake number 1, I've got 2 things that I want to grow the list by. All right, and so if I have a list with 1 and 2 in it, and that's referred to as val, all right, we see that in our visualization, it is itself a list, right? Then append is expecting a value, an individual item value, and we're giving it a list. That's not what it's expecting. It will try and do its best with that. Look what happens. The 7th element is referring to this list. So I've got 9, 12, 1, 14, 5, 4, 19, but then at this index 7 element, I've got at that single element, the list comprised of value 1, 2. I'm going to edit the code and let's do a print of that right now. In order to see what that looks like if I were to then print that mistaken append of a list when I intended a value or a set of values. Notice that I have a print that starts the same as it did before, but now in this last element, I've got a sublist, a list within a list that has the values 1, 2. Probably not what I intended. All right. If I go back to the original conditions, all right, so my list 7 is now 9, 12, 1, 14, 5, and I want to append 42, but I mistakenly put that in an assignment. So as opposed to something that looks like what we did in line 6 or line 7, I'm actually creating an assignment. The right-hand side is my append, but I'm going to assign the result of that to my list 7. So before we do it, let's think about what's happening. My list 7.append of 42 is going to be perfectly happy. This right-hand side is going to do what we think it should. It's going to give me a 42 at index 5 at the end of this list. But append itself is a method that does not have a returned value. Any method that does not have a returned value returns none, and so the expression that I get as a result of append is none. The list was changed, but the append method itself gives back nothing. I then take nothing and I assign it to my list 7. So when I take that step, take a look. My list 7 refers to none, and I've lost the list because nothing refers to it. Right? It's garbage collected. It simply disappears from object space. Right? So the whole point of lines 9 through 11 and line 17 are to show 2 common mistakes that I might encounter when I'm trying to add an item to a list. Okay, we're ready for the next example or sequence of examples. And this,
I don't understand.
in this example, we want to combine two sequences. And ultimately, we're going to take a look at both a list version and a tuple version. All right, we'll start with the list version. Lists, we know, are mutable. And when we've got something that's mutable, we often use methods to affect change on that mutable object. I'm going to go straight to visualization because I start with the same kind of, this is a bad example that I did in my last example. I've got a list that I want to extend a current list by. All right, so my first list is my list 8. My extend list is 743. For the purpose of understanding what's happening as far as when lists are being changed in place versus when lists are being created, I want multiple variables to refer to the same list. All right, so I've also got at line 2 this list alias that is the same as my list 8. They both refer to the exact same list in value space. All right. Visualizing the execution, we start by creating our list and its alias. So both of these, as I just said, refer to the exact same list in value space or object space. And then I create a second list, which is the list that I want to combine with my list 8 in order to get a list that has 8 elements, 9 through 5 and 7 through 3 combined. All right. From the last example, we show that if we simply use the append method, then we get the wrong thing. We get index 5 that refers to a sublist with its own indices 0, 1, and 2. Not what we wanted. All right. And we see again, the print shows me that I'm not getting what I wanted. All right, setting up again, we're going to use a different method. All right, so here we're going to use the extend method. Just like the syntax for append, we're going to see that we're going to have a list expression and then a period and then the name of my method, which in this case is extend, a begin paren, and now instead of an item value, we're going to have our sequence to add. All right, so in line 14, I'm following the same syntax. My list 8 is my list expression. Extend is the name of my method, begin paren, and then the sequence I want to extend it by is called extend list. When I perform that, lo and behold, my list 8 and correspondingly list alias refer to the list that has all 8 elements exactly as I want. And when I print that, I get what I want instead of this sublist within. Now, in order to show the difference between extend and concatenation, we're going to do the same thing, but with concatenation. And so my list 9 is going to be just the same set of values as the original my list 8. List alias 2 is going to have is going to refer to that same list. Extend list 2 is going to be the same sequence 743. At line 22, I'm going to do concatenation. Notice the difference between line 22 and line 14. All right, in line 22, I'm doing concatenation. Concatenation always creates a new copy of the list. All right, so I create a brand new list that is the composed list of my list 9 and extend list 2, and I assign that to my list 9. All right, so when we use concatenation, we're always going to use assignment as well. Right? When I use the extend method, I never use assignment. All right, so we can see that my list 9 became this aggregate list. But take a look at list alias 2. It's still referring to the original one. Because concatenation created a brand new copy, list alias 2 is referring to the wrong thing. It's referring to an unmodified copy. The reason this is important is when we look at functions, all right, when we look at functions, if we pass a list as an argument, then that list becomes the parameter, and that variable is an alias. So if I use concatenation within the function, then the caller is never going to see the results of that because of this aliasing that goes on when I pass arguments. All right? And so in functions, because I pass a list as an argument, the parameter variable is an alias, and concatenation copies the list. So the result is lost to the caller. That's why we use lists, we pass them as arguments, and we use extend or append in the function. We don't use concatenation. Concatenation is also bad when we get lists that are large. When we're dealing with data that has any size at all, making a copy of a list by using concatenation ends up requiring a lot of time and space to do, and we want to avoid that. Okay, that's the end of that example. So our next example is looking at combining two lists, but considering what do we do when we have tuples instead of lists. All right? So here I've got my tuple 8, consists of the same values as I used in the last example. I make an alias, and this is the second list that I want to create the composite with. So I want the tuple 9, 12, 1, 14, 5, 7, 4, 3. We take a look at the visualization of this. We start by trying to do the same thing we did with lists. All right, we learned that lists are much more efficient to do extend, to modify in place. All right, let's try and do the same thing. So my tuple 8 is created. I've got an alias to that same tuple. Here is the thing I want to add to it, and then I try and do an extend. Tuples don't have an extend method. Because they're immutable, they don't even let that method exist. Instead, I've got to use concatenation. All right, and so I'll edit that code, comment out my mistaken use of extend. And now I'm going to use concatenation. Concatenation creates a brand new copy. All right, so it's like construction. I'm creating a brand new tuple that didn't exist before, whose values are coming from two different tuples, its operands. All right? Once I've got that created, that's created over here in object space, I'm going to assign that to my tuple 8. Right? And I get the composite. and that got assigned to my tuple 8. Now notice that tuple alias, that still refers to the original. There's nothing we can do about that because tuples, by definition, are immutable. They can't be changed. And so when I need to create a composite, I've got to use concatenation, but that's always going to create a different object. Our next example is going to take a look at the problem that we originally solved with append. We used append to add a single item to an existing list. Well, if we have extend and we have concatenation as two ways of taking two sequences and putting them together, I could use that, and when I want to add a single item, instead of adding the item, I can create a list or a tuple with that item and compose them using extend or concatenation. Okay, so that's what we're going to see here. I'm going to skip the this what happens if I try and do append, all right? Because we should understand that if I do append on a tuple, that method doesn't exist. We'll get an error. So I'm going to continue on. I create my tuple and create my tuple alias. Now you might try and do what I'm showing in a comment line in line 10. All right, I've got my tuple 7. I'm going to create a one element tuple that has the value 42 that I want to add on to this sequence. And so I put parent 42 and parent. Unfortunately, parent 42 and parent means something different. It means that we're applying precedence to the value 42, and that gets me still the value 42, but it's still an integer. That is not creating a one element tuple. That's the integer 42. So the correct syntax for creating a one element tuple is to have the value followed by a comma and then nothing following the comma inside the parentheses. So it's like a construction, but for one element tuple, we need 42 comma. Right? So if we show that, we can see that my tuple plus 42, now that by itself didn't do anything because it created that value in value space, but because I didn't do assignment, it got lost, went into the ether. Instead, in line 12, that's the correct incantation for taking a single value, 42, creating a tuple out of it, and then using concatenation to combine it with a sequence that already exists. Right? If we're using a list, we can do the same thing. I create the list and an alias. If I say my list plus 42, that actually is going to create, because concatenation creates a new object, it will create a list with all 6 values in it, but it wasn't assigned. So if I'm using concatenation, I need to assign. In line 19, I'm assigning. And that gets me what I want. Now, the last example, I actually had a mistake there. The whole idea of this example was to take a single element, make it into a sequence with one element in it, and then to use our mechanisms of either extend or concatenate to get that done. And so I want to use extend if the argument is a sequence. All right, so line 24 is now corrected. And if we get down to line 24, mylist7.extend with the 42, and we've got the list that we desired. Right. Typically, it's better to use the right method for the right job, the right tool for the right job. So if I've got a single element to add, I use append. If I've got a sequence to add, I use extend. couple comments in terms of example about copying. All right. Sometimes when I have a list, I really want a copy of that list because I want to preserve the original list, and then I'm going to do something with the copy of the list. Well, how do we get that done? Well, I'm showing a couple of the main ways that I can do that here. We'll do it in the visualization. I start by creating my list 10 as having the 5 values 9, 12, 1, 14, 5. All right, create the alias just so that we can have another reference to the original. And now I create my list copy 1, which is my list 10.copy. So we're learning a new method, the copy method, which is a method of a list. I take an existing list, my list 10, and invoke the copy method on it. That creates a brand new copy that's in value space. I assign that to something, my list copy 1. Right? And so you can see in value space, I've got the original and I've got the copy. I do it again, but if the expression before the copy method is list alias, it works the same way. Whatever my expression is, if it refers to a list, the copy will create a brand new copy of that list. And now I've got a third copy. In addition to the copy method as a way of getting a copy of an existing list, I can also use slicing. Slicing always creates a brand new copy when it creates its sublist. And so if I use slicing and say, create a sublist, but that's not a proper sublist, it actually includes every single element, that's a way of getting another copy. So I take my list 10, and at the end, I've got a slice that says start at the beginning and go up to and including the end. And I've got yet a fourth copy of the list. Now, with tuples, if I create a tuple and a list, if I were to do the copy method, I'd get that same method not supported for tuples. And so I go straight to the second way of creating a copy. I can use a slice on a tuple and get a brand new copy. Okay. Now, interestingly, if we look in value space, because this particular tuple sequence, a tuple with 9, 12, 1, 14, 5, is immutable, it can't be changed. Well, it's more efficient for me to only have exactly one version of that in value space, right? Because nobody can change it out from under me from using a different variable reference. All right? So that's why all three of these, in fact, for efficiency's sake, are referring to the exact same tuple in object space. Right? So that's copying. Another type of mutation that is common is removing elements. All right, we may want to remove an element, and we've got a couple of different ways of removing elements. Let's use my noteboard to give us a little bit of an outline to follow. All right, if we want to remove elements from a list, and note that tuples need not apply. Since tuples are immutable, it doesn't even make sense to say I'm going to remove an element from a tuple because it would have to be mutable in order for that to happen. All right? So my examples within removal of elements from a list, I can remove a single element based on its index. I can remove a single element based on index and get the value of the removed element. And I can remove a value based on its value. So the way that we do this, removing a single element based on its index, we're going to use the del statement. Removing a single element based on its index and getting the value, we're going to use the pop method. And removing a value in a list based on its value, we're going to use the remove method. Right? Notice that my noun in each of these cases, a del is a statement, whereas pop and remove are methods. Right? So del is going to look a little bit different because we're issuing a statement as opposed to invoking a method. Okay, let's look at this visualization. I create my list 11, which has a whole bunch of elements in it. I need a little bit more room for this. All right, so we start at value 9 at index 0 and go to value 6 at index 9. Deleting, I specify the name of the list, my list 11, and then use the access brackets to say which one, and 2 is the index. So I'm going to remove that index 2 item, and lo and behold, it's gone. Note that all of the other indices change. The value 14 used to be at index 3. Now it's at index 2. So we've got to be a little careful when we start using del that we're not explicitly or implicitly assuming the indices of anything that follows that as being the same after that operation. The indices have changed. Now it turns out that just like with assignment, I can actually use a whole slice. And so I can say, I want to delete my list 11 from -3 to -1. Let's think about what that slice means to start with. -3 means that, well, 8 is -1, 7 is -2, 6 is -3. So I'm going to start at index 6, and I'm going to go up to, but not including, index 8. And so that means that I am trying to remove the subsequence from index 6 to index 7, or the values 7 and 4 from this. And lo and behold, that's what that did. Right, pop is different from delete because pop is a method. That means that I'm going to invoke it on a list. I'm going to give it arguments. In this case, if I give it no arguments, implicitly that means I'm going to pop the index 0 element, the first element of the list. Pop gives back a value. This value 9 that is at index 0 in this list becomes the value returned, and that will get assigned to val1. So whenever we do pop, we almost always do it in assignment and assign to a value. And so the 6 came off the list and it got assigned to val1. Pop doesn't have to just use the first index. We often do that because it's a data structure that allows us to add things and take things off of the front of the list. But we can say, I know what I'm doing. I want to pop index 2. Pop is going to say, I'm going to remove index 2, and I'm going to give you back that value, that 14 in this example, as a value returned from pop. And now I've done a second pop to remove a value and obtain its value as a side effect. In line 17, I'm saying, let's remove 5. All right, so now the value or the argument for the remove method is the value that I want to find. I'm going to look through this list in turn and try and find a 5. Well, it turns out there are 2 different 5s. Remove is going to remove the first one. right? And so it's going to take this list and remove this first 5. The 3 moves up and the second 5 moves up, but the second 5 is still there. Now, if I do remove and I specify a value that does not exist in the list, then what we get is a value error. So this is another case where I would get an error return, and I would look and say, list.remove x, x is not in the list. So if I read the error, it really tells me what happened, what went wrong, so I can go back to my code and do the right thing. Now, it might be that I need to support the case where a value is not present. If I need to support that and I don't want this error exception to occur, I've got one of 2 choices. I might search for it before I remove it, or I can use exception handling. All right? Exception handling is another topic that we don't often cover in a first Python class, but I'll have a short description of what happens for exception handling as another review video. All right, our last category of examples are searching. Okay, so searching comes in a couple of different varieties. I may want to ask the question simply, true or false? Is the thing that I'm looking for present in the list? That's one way of answering a search question. A second way of answering a search question is, don't just tell me true or false, is it in the list, but tell me where it is in the list. One of the benefits of a list is that it has order. The indices tell me about the positions of values. Give me that position. Give me that index associated with the value that I'm searching for. And third, I may want to know, how many times is the thing that I'm searching for present in the list? In that case, I'm asking to find the count of item occurrences. All right, so that's what this example here is going to do. For present in list, we're going to use the in operator. All right, for finding the index, we're going to use the index method. And for finding the count of item occurrences, we're going to use the count method. All right, so that's what we're going to demonstrate here. So we'll go to the visualization for that. All right, in this case, I'm creating my list 12, and just to show you that data types matter, I'm actually going to create a list that has some integers as well as some strings. And interestingly, some of the strings have numbers, as in number characters, as part of the string. All right, so in this list at index 0, I've got the integer 9. At index 1, I've got the integer 12. At index 2, I've got the string whose sequence of characters is a single character, the character 1. At index 3, another integer. At index 4, another character string, and so forth. All right, so with that, we're going to use the in operator. All right, so at line 6, I'm going to say result 1 is equal 5 in my list 12. So the right-hand side is a Boolean expression. All right? In this case, I'm going to use a Boolean expression and assign it to a variable. I could use a Boolean expression in an if statement. I could use a Boolean expression in a while statement. Right? Any time that a true false value might be appropriate, I could use a Boolean expression. And so I can use in this context to create that Boolean. So 5 in my list 12. Well, as humans, we look down this list and say, yeah, at index 6, I see the integer 5. All right, so I expect that to be true. Result 1 is in fact true. All right, then I'm going to look for 1 in my list 12. Now notice that the in as an operator has two operands. The right-hand operand is the name of my list or a list expression. The left-hand operand is what I'm looking for, my search term. My search term has a data type associated with it. In this case, I've got the constant value integer 1. Right? And if I search through this list, there is no integer 1 in this list. There is a string whose value has the 1 character in it. So that's present in the list, but the integer 1 is not. So I expect result 2 to give me false. Is there a 0 in my list 12? No, there's not. I expect that to be false. Sometimes I want to negate, and while I could say a not of 0 in my list 12, Python allows a more natural sounding is 0 not in my list 12. So not in becomes a compound operator. All right? And that would be true because it's false that 0 is in my list 12. Therefore, it's true that 0 is not in my list 12. All right? So that's the in operator. The index method. I specify the name of my method. I'm sorry. I specify the name of my list and then say the name of my method, index, and substitute in what value am I looking for. So my list12.index5 is going to search this list, and instead of giving me the value 5, it's going to give me the index where it found. All right? In other words, it's going to give me back a 6. All right? Index of the string 1, because that actually is found, it's going to give me 2. We'll come back to this in just a moment, but we want to understand what does index or count do in the case that it does not find a match, if the search fails. All right, now on count, I ask how many times does 1 occur? What does it? It's not there at all. I get the value of 0. How many times does 12 occur? Well, I see 12 at index 1 and I see 12 at index 5. It occurs twice, and so C2 gets the value 2. If I look for count of string 4, this is an integer 4 at index 3. That will not contribute to the count. However, the string at index 8 has the same value that I'm searching for, and I should get a 1. Okay, let's figure out what index does when I give it something that's not present. All right, so now I'm about to execute line 13. What does it do? It gave me an error. It says value error, 1 is not in the list. All right, that raises an exception, and so if I need it to be the case that that index doesn't cause an exception and allows my code to continue, I might need to do exception handling or do a separate search. Okay, that covers the spectrum of operations that we need to be facile with that work on lists. So this brings to a conclusion the second of my list review videos. Thank you for your attention.